Today we are learning about the surface areas of pyramids and cones. This is the 11.3 notes. To find the surface area of a tent, we need a new strategy for surface area because what we've learned so far is for prisms and for also cylinders. Now we're going to be talking about pyramids and cones. So to find the surface area of a pyramid, you need three parts. One is called the base edge. We will label this S. Base edge is the length of one of the edges of the base that it sits on. We also need to know the height, which is the height going straight from the center of the base straight to the top vertex. And then we also need to know the slant height, which goes from the midpoint of one of the sides, or I should say one of the base edges, straight up to the top edge, or excuse me, top vertex. Now I'm going to show you why. Let's say that we want to find the surface area of this pyramid. What we need to know is that if I were to draw the net for this pyramid, and you guys can go ahead and grab your nets to make sure that you know what this looks like, is that if we keep the base where it was, that being a rectangle that is 6 by 4, if you fold the front pyramid, or excuse me, front triangle down, the back triangle back up, and then the right lateral side and the left lateral side, they all are triangles that come down, okay? That is the net. What we need to know then is what is the area of all of these triangles. So we need to know the height of each of these triangles. We know their edges, their bases, 6, 4, 6, and 4. What is that slant height? Now, these dotted lines that I'm drawing in correspond to this edge right here. That is the slant height. What we know is that if we draw a line straight from the center of the base to the center of one of those base edges right here, and then we draw a line from the center of one of those base edges to the top vertex, and then draw a line from the top vertex down back to the center of the base, what that creates is a right triangle. Now we know that the distance from the center of the base to the outside edge, or the base side, base edge I should say, would be half of this distance. So if this is 6, then this would be 3, because it's halfway across. So we know that the height of this triangle, straight up, would be 8. The base right here would be 3. And we can find that slant height by using Pythagorean's theorem. So we would do 3 squared plus 8 squared equals the slant height squared. That's our new hypotenuse, or C. Slant height, we use a cursive L. Squared is equal to 3 squared plus 8 squared, so 64 plus 9 is 73. Take the square root of both sides, you get L equals the square root of 73. I'm going to leave it as a square root. You guys can round that off and find the decimal, but no need to. So, on these triangles, that have a base of 4, their slant heights would be the square root of 73. if we were to turn it sideways and we were to draw the slant height of the front edge, this distance would be 2, the height would still be 8, and we need to know that C. So if you turn it to the left, 2, 8, slant height makes a right triangle. Do the same thing. 2 squared plus 8 squared equals the slant height squared. So these slant heights, which are the height of those lateral triangles, are the square root of 68. So now that we have the base and the height of each of those triangles, those lateral sides, and we also have the length and the width of the base, we can find all of our areas. So area of the rectangle base is equal to 6 times 4, which is 24. We'll just say that's square units. The area of the front and back triangle are both 1/2 times their base, which is 6, times their height, which is square root of 68. But there's 2 of them, so I multiply that by 2. And I get, for those two, 49.48 square units. And then for the area of the left and right triangles, 1/2 times their base, which is 4, times their height, which is the square root of 73. Now there's 2 of them, so you multiply that by 2. And you get 34.18. Then once you know area of the base, area of the front and back triangles, and then the left and right triangles, you add all those together. And the whole surface area is equal to 107.65 square units. Now let's do a problem from the homework. In the homework, what you will see is a bunch of bases with all the same lengths on the side edges. So I gave you guys kind of a harder problem right here than what you are going to come across in the homework. on this problem, you have to do two slant heights because they have two different base lengths. Therefore, their slant heights are going to be different, which we showed. But if all the sides on this base of the pyramid are 12, then all of the slant heights are going to be 11 inches also. All of those are 11. So we know what the net looks like. It is 12 by 12. So that means that all of these triangles have a base of 12. And then they also gave us the slant height, which is 11. And that slant height is also the height of the actual triangle when it is folded down. So what you can do is say, all right, I know the base, or the area of that square base, is equal to 12 times 12, which is 144 square inches. The area of each of those triangles is equal to 1/2 times their base, which is 12, times their height, which is 11, which is 66. But there's 4 of those, so I'm going to take 66 and multiply by the number of triangles, or the number of lateral sides. And I get, for the lateral sides, their areas are 264 square inches. Now that I have all of those triangles, the lateral sides and the base, I can add those two numbers together to get the total area, surface area, of 408 square inches. But there might be an easier way. What if, instead of doing 1/2 times the base of 1 times 11, and then getting 66 and multiplying by 4, what if we took 1/2 times the base times 4 times 11? It's essentially doing the same thing. But what you see is that the base of 12 times 4 would be 48, which is the perimeter of the base. Can we save some steps? So 1/2 times the perimeter of the base times the slant height. Let's see if we get the same thing. Sure enough, we do. So maybe instead of doing all of the triangles individually, then multiplying by the number of triangles, what if we do 1/2 times the perimeter of the base times the slant height? That might be quicker. Either way is fine by me. But this only works when we're working with a base that has all of the same length edges. And that's what we're saying here. Lateral area is equal to 1/2 times the perimeter times the slant height. To find the total surface area, you take this lateral area and you add the base area, which is usually the length times the width. Now let's do a harder one. If I were to draw this out, I see that this is a hexagonal prism, excuse me, pyramid. So I'm going to draw a hexagon. And I'm going to assume, because they don't give me more than one edge length, I'm going to assume that all of these edges have a length of 4. And then they give me the slant height. So I'm going to draw those triangles in. And the slant height is 8, so that means that the actual height of one of those flattened out triangles is 8 meters also. So I'm going to start with the area of those triangles. I realize that there are 6, and let's say that if I want to find the lateral area, I use my 1/2 times the perimeter times the length. Saves me some steps. Now my perimeter is 4 plus 4 plus 4 plus 4 plus 4, or basically 4 times 6, which is 24, times the slant height of 8. And I get 96 as the area in square meters of all of those triangles put together. Now, the base area is a little trickier. We have a base of a hexagon, a regular hexagon, and we know what to do with those. So I'm going to look at this separately. When we have a regular hexagon, you say, all right, can I draw in my triangles? And once I draw my triangles in, do I know the height and also the base of one of those triangles? Sure enough, they made it easy by giving us the base of 4 meters and a height of 2 times the square root of 3. So find this area. You take 1/2 times the base of 4 times the height of 2 times the square root of 3, and then you multiply that by however many triangles there are inside of that regular hexagon, which is 6. So our base area is equal to 1/2 times 4 times 2 times the square root of 3 times the 6 triangles that fit inside. What I'm going to do is I'm going to multiply everything that isn't underneath a square root. So 1/2 times 4 times 2 times 6. And I get 24. And then because I didn't multiply by a square root of 23, or excuse me, a square root of 3, I'm just going to call this 24 square root of 3. That's also square meters. Now, if I want to know the total surface area, I have to add the lateral area plus the base area. So 96 plus 24 times the square root of 3 square meters. That is the exact answer. Notice that I didn't multiply by the square root of 3 because that would give me a long decimal. Now, if you wanted to get the long decimal, you could still do that. Do that in your calculator. 96 plus 24 times the square root of 3. You get 137.4. 0.57. But I believe that the book wants you to give that answer. I could do more of these. No need. I'm going to do... this one with you. Number 5. You guys go ahead and do number 3 and 4. Number 5 with you guys. Here we go. So what we see is that the actual height of this pyramid is 8. And the distance from the very center of the base to the midpoint of one of the base edges, that is a length of 5 times the square root of 3. What you realize is that height and the edge that goes from the center to the midpoint of one of those edges make a right angle, and then going back from the midpoint of one of those edges to the very top, that creates a right triangle. We have a length of 8, a length of 5 times the square root of 3, but we don't know what that slant height is. We need to know what that is. We also realize that's our hypotenuse, and we have the 2 legs. So let's set up in the Pythagorean theorem. 8 squared plus 5 square root of 3 squared equals that slant height squared. 8 squared is 64. Now, when you have 2 factors being multiplied inside of a parentheses, and you're squaring the whole thing, what you do is you square both the 5 and the square root of 3. 5 squared is 25, being multiplied by the square root of 3 squared. Square root of 3 squared is 3. Now let's simplify the left side. 25 times 3 is 75, plus 64 is 139. That is equal to the slant height squared. To find the slant height, you take the square root of 139, and I'm going to leave it just like that instead of getting a decimal. Draw out the net so we can see what this looks like. And what we just found was that slant height was the square root of 139. The base of one of those triangles is 10, 10, 10, 10, 10. All of those heights are square roots of 139. And we know that the distance from the center to the midpoint of one of the edges is 5 times the square root of 3. Now let's say that we want to find the lateral area, or the area of all those triangles that go up to make the point of the pyramid. We take 1/2 times the perimeter times the slant height. What is our perimeter? Well, that would be 10 plus another 10, 10, 10, 10, 10. That is the perimeter of our base. 10 times 6, 60, times the square roots of 139. I'm going to leave 139 underneath the square roots. 1/2 times 60 is 30, so the real answer is 30 times the square root of 139. Now the base area. This is another regular polygon. If you need to, draw it out to the side. No, I'm going to actually draw in our new slide. Our base is a hexagon. We know that the edges are 10 and that the distance from the center to the midpoint of one of the sides is 5 times the square root of 3. Essentially what they gave us was the height of one of the triangles, the isosceles triangles that are drawn in. Since we know the height of one of those, and we also know the base of one of these isosceles triangles, you can take area of one of the triangles equals 1/2 times the base of 10 times the height of 5 times the square root of 3. Whatever that is, you multiply by 1, 2, 3, 4, 5, 6 triangles. And multiplying it by 6 gives you the whole area of the base. So I'm going to go back over here, write it down. The base area equals 1/2 times the base of 10 of one of those little triangles drawn in times the height of 5 times the square root of 3 of one of the heights of the little triangles times how many triangles are drawn in to our base, which is 6. Multiply that all out. I'm going to multiply everything but the square root of 3. 1/2 times 10 times 5 times 6 equals 150 times the square root of 3. And those would both be square centimeters. Now that I have my lateral area and my base area, add them up. And that would be 30 times the square root of 139 plus 150 times the square root of 3. You might be able to leave it like that, or you might want to put it in the calculator to see what the decimal would be. And you get a total surface area of 613.5 square centimeters. Now these are a lot of work, so you guys are going to have to work hard. Also, if anybody catches a mistake, talk amongst it with yourselves. You guys can email me, let me know, hey, Mr. Duffy, there was a mistake in one of your problems. Might have been a mathematical error. That is totally fine. Make sure you catch it and don't do the same thing. I'm going to leave number 6 to you, and I'm going to move on to cones. Now, before, the lateral area of a pyramid was 1/2 times the perimeter of the base times the slant height. Now, in place of the perimeter of our base would be what goes around the circle, or in other words, the circumference. We know that the circumference is 2 times pi times r. So, if we take 1/2 times 2 times pi times r times the slant height, you see that 1/2 times 2 equals 1. So they kind of cancel each other, and you get pi r l. So anytime that you see or draw the net of a cone, you need to realize that this part has an area of pi times the radius of the circle times the slant height. And then obviously the area of the circle is pi r squared. And what you do with pi rl and pi r squared is you add them to get the entire surface area. Now let's do it. Okay, so I need to find both the base area, because the surface area is equal to the base area plus the lateral area. Let's work with the base area first. Base would be the circle. So I'm going to have pi times the radius squared. Pi times, what's our radius? Well, I see my diameter is 6, so my radius would be 3 centimeters squared. 3 squared is 9 times pi. I'm going to leave it as 9 pi square centimeters. The lateral area. If I were to draw this out, I would fold the circle up and the lateral area down. It's going to look like this. I already did the math for the area of this circle with a radius of 3. And now I need to do pi times the radius times the slant height. And hopefully I don't lose everything. Fantastic. Okay, it might be coming back. Hopefully. This has happened before. Okay, at least I still have my recording. I realize this is long, but it'll work. Alright, so we recovered it, and I still have my video going. Okay. So back to it. The lateral area is equal to pi times the radius times the slant height. And we have a radius of 3. But we don't know that slant height. What we do realize is that the radius, the height of the cone, and the slant height create a right triangle. So my right triangle looks like this. Radius of 3 right there, height of 4, and then the slant height, you have to realize if you plugged it into the Pythagorean theorem, you get 3, 4, slant height of 5. And that's just one of those special triangles that you can remember. So we have a slant height of 5. And then you say 3 times 5 is 15 times pi is 15 pi square centimeters. Once you have both, you add them. 9 pi plus 15 pi equals 24 pi square centimeters total. And that is surface area. Let's do one from the homework. So I drew this cone out. It would look like this. The circle has a diameter of 12, which means the radius is 6. And then they gave us a slant height, which is great. So surface area equals lateral area times or plus the base area. Let's do the base area first. Pi times the radius squared, which is pi times 6 squared, which is 36 pi square centimeters. Lateral area equals pi r L. Pi times the radius of 6 times the slant height of 18 equals 108 pi square centimeters. When you have both the lateral and the base area, you add them. And that is it. The rest I will leave for you guys to do on your homework. Quite a few of them, but this video has been long enough. Good luck.